before we get into the chapter, let's try to understand the basic, idea of what electricity is. So, can anybody tell me what do you mean by electricity, or what is electric current? What do you mean by electric current? We all understand that electric current is an important uh, commodity in our daily lives, right? So, what do you mean by electricity, or what is electric current? In your own words, you can tell me. Yeah, any volunteers?
Rate of flow of electric charges in a conductor.
Exactly. So when charges are flowing, the rate at which they are flowing in a conductor, you say that there is a current, isn't it? So the rate of flow of charges, only charges will be current. Only if charges flow will you say it is current? Not necessarily, isn't it? You have something called as water current. There is wind current. When you say there is a wind current, when there is a rate of flow of wind, isn't it, with respect to time, then you say that there is a wind current. When there is a rate of flow of water in a particular direction with respect to time, then you say that that is a water current. Okay, so current can be of different types. So in this particular chapter, we are going to restrict our study to electricity or electric current alone. Okay, which is basically defined as the rate of flow of charges, as one of you said. Okay, so I'll just give you the basic definition. So the rate of flow of charges. So where can charges flow? Rate of flow of charges in a conductor. Okay, so we call it as electric current. I hope that's clear. So what are the charges that are flowing? Which charges are responsible for the flow of current in a conductor? There are different types of charges, and you have been learning that from quite long. So what is the nature of the charges that flow in a conductor, which is responsible for electric current? Anybody? So many types are there in charges. Yeah. What are the type of charges responsible for the flow of electric current? You must be knowing this. Is it a proton? Is it a neutron or electron?
An electron.
Exactly, it's an electron, right? So the rate of flow of electrons in a conductor would constitute electric current in that particular conductor. Very simple. So here, let us try to imagine there is a conductor here. So I've taken a piece of copper wire. Okay, I've enlarged it. Now you can see. Now there are electrons which are going to which I'm going to pass through this conductor. Now if I want electrons to pass through this conductor, I need a source that can supply electrons, right? So therefore I am going to connect a cell or a battery. Okay, I am connecting a cell here. There are two lines, one positive and one negative terminal. So I'm going to connect it. Okay, so I'm going to connect it to a switch. What you see here next to the cell is a switch. I'll just write it here. Okay, or we also call it a plug key. Okay, so this is a plug key, this is a cell. Okay, the cell is going to provide the electrons. It is going to provide rather a potential, we say. Now due to that potential, electrons are going to flow in this corresponding circuit, and hence the current is going to flow. Now we try to understand that. So therefore I'll mark the terminals of the cell. The terminals of the cell are positive and you have negative, right? So we all know that electrons are negatively charged, isn't it? So I'm representing using negative charges. Okay, so randomly I'm going to place the negative charges. Now these negative charges, how are they going to move? Let me just name it. This conductor, let me name it as X at this end and Y at the other end. I want one of you to tell me how these electrons are going to move. Is it from X to Y or from Y to X? How they are going to move? Yes, it's okay even if you're not giving me the exact idea. You can just give it a try. Okay. How do the electrons move in a conductor?
Sir, X to Y, sir.
Here they are moving from X to Y. Okay. Why is it X to Y? Any particular reason you have?
Sir, positive to negative, sir.
Positive to negative. சரி,
Yes,
ஏன்
negative போகும் சார்.
positive? Is it
எலக்ட்ரானோட
positive
ஃப்ளோ
to
வந்து
negative?
நெகட்டிவ் டு பாசிட்டிவ் போகும்.
எலக்ட்ரானோட ஃப்ளோ வந்து நெகட்டிவ் டு பாசிட்டிவ். எக்ஸாக்ட்லி. கரண்ட் வந்து எக்ஸ் டு ஒய். இப்போதான் தெளிவா சொன்னேன். ஓ, கரண்ட் ஃப்ளோஸ் ஃப்ரம் எக்ஸ் டு ஒய், பட் எலக்ட்ரான்ஸ் ஃப்ளோ ஃப்ரம் ஒய் டு எக்ஸ். தட்ஸ் வாட் யூ செட். வை எலக்ட்ரான்ஸ் ஷுட் ஃப்ளோ ஃப்ரம் ஒய் டு எக்ஸ்? ஏன் கரண்ட்டும் எலக்ட்ரான்ஸ் ஒரே டைரக்ஷன்ல ஃப்ளோ பண்ணக்கூடாது? Electrons and current direction.
சார் எலக்ட்ரான்ஸ் வந்து நெகட்டிவ் சார்ஜ் சார்.
சரி.
எலக்ட்ரான்ஸ் இப்போ இப்போ பாசிட்டிவ் டைரக்ஷன்லயே போனா அது ரெப்பல் ஆயிடும் சார்.
ஓகே, கரெக்ட்.
இப்போ வந்து நெகட்டிவ் டைரக்ஷனா போனா அது வந்து ரெப்பல் ஆகாது சார். அந்த கரண்ட் கூட அட்ராக்ட் ஆகும்.
Okay. Yes. So therefore the basic idea is, so initially we take current direction as the current direction always is from positive to negative. Now why we say positive to negative? That is because current can only flow from a higher potential to a lower potential. Now this is the basic idea that we need to have. Current அப்படின்னு சொன்னாலே current is always going to flow from positive to negative. That is, positive means something which is higher, negative means something which is lower. Now how do we try to understand this analogy? Have you been to waterfalls, right? Waterfalls. Now how does a water fall in the waterfalls? Will it flow from top to the mountain to the bottom, or from the bottom will the water climb up the mountain and go?
Top to bottom.
Exactly. Why it flows from top to bottom? The water at the higher potential, right? When it is at a higher potential, it is easy to flow to the bottom. Water will never go in the opposite direction. From bottom to top, it's not possible, isn't it? Because water on the top of the mountain is at a higher potential. Now, what is meant by potential? The height with respect to the ground. Are you understanding? Now, if we are standing on the ground, that the ground is a reference level. A mountain is at a higher potential from the ground. Do you agree? Isn't it? So that is the basic idea. So that is the reason water will flow from the region of higher potential, means from a higher height to a lower height. It cannot go in the reverse direction. Even in our homes, if we are living in tall high rise buildings or apartments, have you heard something called as an overhead tank? Isn't it? Water comes from the overhead tank from our to our house, right? Or to our homes. When you open the tap, water comes. How does it come? Do you need an external motor for that? Even without a motor it works, right? Even when there is no power, still the water is running in the pipes and it reaches our homes. There is no external energy required. Can anybody tell me why? Why doesn't it require any energy?
Because the water is from higher potential, sir.
Yeah,
The tank is fixed at the top of the roof.
exactly. It is overhead. That's the reason it is called an overhead tank. So it is above our heads. That's the reason, the potential is also higher and the water flows down the pipes. Okay. So what happens to the water eventually as it flows down the pipe? The potential energy gets converted to kinetic energy when it starts moving, right? And therefore it reaches the taps and we are able to access the water. But what happens when the water is getting exhausted or water is used up in the overhead tank and you have water in the underground tank, or it is also called as sump, SUMP, right? Or in the underground tank. So you wanted to send it overhead from the basement or from the underground. So what do? Won't that happen automatically? Water from the ground, can't it climb up the pipe and just reach the overhead tank on its own? Yeah,
Because it's from lower potential,
exactly.
So we need some external force to push the water upwards.
Perfect. Okay. So when water is at a lower potential, just like the underground tank, if you want to send it overhead, you need an external driving force that is given by a motor or a pump, right? You have different types of pumps. So yeah, you switch on the pump. So the pump is going to do the work of pumping it or sending the water from lower potential to a higher potential, because it's not possible. There is no current in that particular direction. That's the reason you have an external driving force, which is called a motor. Correct. Now, have you even seen the cars, okay, or your vehicles? It can be two-wheelers or four-wheelers. Okay. Now, coming down the ramp is very easy. You know what is a ramp, right? If you have been to
Yes,
shopping
sir.
malls, you can see that there is something called as a basement parking system, right? So you can see that when you want to park your car, or that's your four-wheeler or two-wheeler in the basement, there is a big ramp which takes you to the basement. I don't know if you guys have observed, right? Even in Brookfields Mall, there is a basement parking system. If you guys have gone there, you would have observed. Now, to go to the basement, even with your engine off, okay, just you keep your vehicle in neutral gear, still the car will move. Have you observed? You don't.
Yes, sir.
Yeah, that is enough. You need not switch on and drive. Even with on the neutral gear, just with the engine off, and still your car will go. Just brake pedal you need to manage. That's enough. But the same thing, if you're coming out from the basement parking, if you want to come out of the mall, will it's you need to keep your engine on or engine off.
Engine on, sir.
Yeah, you need to provide the accelerator. You have to hit the accelerator pedal. Only then you can bring it out. So therefore, here comes the concept of uh, potential. So potential difference is very, very important for the flow of current. Now this potential difference is provided by a cell or a battery. Okay. Now what is the difference between a cell and what is the difference between the battery? We will see. Okay. So now I hope it is very clear to you guys how current flows. Current flows always, I'll write here for your understanding. So current flows from where to where? Current flows from,
Higher potential to lower potential.
yeah, flows from higher potential. Higher potential means I'm talking about positive terminal in this case. Okay, higher potential, that is positive terminal, to lower potential. Lower potential means it is the negative terminal. That is how current flows. Okay, that's how the current is going to flow. Now, when you are going to look at the flow of electrons, okay, current was initially, it was discovered. Okay, so if you try to understand why it is like this, the direction of current is being taken from positive to negative, but electrons were discovered and they were later found that they have a negative charge. So direction of flow of electrons is going to be in the opposite direction to the flow of current, because electrons are negatively charged. And can you see the cell is positively charged on the left side? So opposite charges attract each other, right? So that's the reason electrons flow in the opposite direction to the flow of current. So electrons will flow like this. Electron is flowing from y to x, current is flowing from x to y. Okay, that's the reason. So electrons being negatively charged get attracted to the positive terminal of the cell. Okay, that's the reason electron and current directions are both opposite to each other. Okay, now we'll try to understand what is a cell and what is a battery. Okay, who can tell me what is the difference between a cell and what is the difference between a battery? Anybody? I'm just drawing here the diagram so that you can find out what is the difference. So did you get the difference by looking at the diagram that I've drawn? So what is the difference between cell and a battery? A cell, yeah,
Is single, but battery is a combination of cells.
exactly. A cell is a fundamental unit of potential difference. Okay, cell is a single unit, but battery is a combination of two or more cells. Okay, so cell is a fundamental unit of potential difference, So I will use potential difference short form as PD. Don't get confused. Battery is a combination of two or more cells. Okay, that's the basic idea that you will have to have. So if I say, for example, so I'm just trying to give you one example for understanding it much better. Okay, so let us take a cell, for instance. Okay, so I'm taking a cell here, and let us say the cell is having a voltage of 2 volts. Okay, volt is nothing but the potential difference of the cell. So this 2V is we will read it as 2 volts. When you read it, you will say 2 volts. And then you will mark the potentials. The bigger line is positive potential, the smaller line is negative potential. Okay, this is a cell. Now, what is what will be the potential of a battery consisting of 4 cells? What is going to be the potential of the battery consisting of 4 cells? If 4 such cells are there, what would be its potential? What is the answer?
8 volts.
Yes, it is going to be 8, right? 4 twos are 8. So when 4 cells are there, the diagram will look like this: 1, 2, 3, and 4 cells. So here it is 4 times 2 volt of one cell. So therefore you will get 4 times 2, which is 8. So it will be 8 volts. So the answer is 8 volts. Is it clear? That's it.
Yes, sir.
Yeah. So this is the basic idea. So now I am introducing the concepts one by one. So this is all about a cell and a battery. So you now know what is a cell and you know what is a battery. Okay. Next, we are going on to the basic circuit elements. So we'll see all the basic circuit elements. Okay. So these elements are very important. One by one, we'll see. First one, we have seen what is a cell. Okay. I'll anyways give it again. So this is a cell. Cell is basically a source of potential difference, and I'll also give you the unit. The unit is volts. Okay, so this is the first one. Moving on to the second one. Second one is a battery. Also is the same thing. I'm not repeating it. Second is this symbol. Has anybody seen this symbol? What is this called?
Resistance, sir.
Resistance, sir.
Very good. This is a resistor. Okay, this is a resistor. And what is a resistor? Resistor offers resistance to the flow of current or electrons. Okay, it will not allow current to flow easily. It offers resistance to the flow of current. Let's put it that way. Resistance to current flow. And what is the unit of resistance? Anybody?
Ohms.
Yeah, it is called ohm.
Ohm, sir.
Yes, the symbol for ohm is this. Okay, the symbol for volt is this, V. Okay, ohm is this inverted U symbol, and V I have written on the top. Okay, so this is the second component that you will have to know. Third one. So we're done with resistor. And yeah, have you come across this symbol? What is this symbol? What is this symbol? This or this? Anybody? This is called, any idea? Anybody knows?
External resistance.
Pardon?
External resistance, sir.
No. This is actually called varying resistance, which is called rheostat. Okay. This is called a rheostat. Okay, I'll write it here. The name is rheostat. Now, what does this rheostat do? Okay, it is a variable resistor. What do you mean by a variable resistor? whose resistance can be varied, changed. Okay. Whose resistance can be changed. It is also called as a slide wire rheostat. It is often called as a slide wire rheostat, which is used in the laboratory. Okay. You can slide the rheostat. There is a slider on the top by which you can vary the resistance. Is it clear, children? So this is all about the rheostat. What is the unit of rheostat? The unit is ohms, because again you can vary the resistance, so unit is going to be the same. Is it clear? So that is about the rheostat. Next, fourth one. What is this symbol called?
Ammeter, sir.
Ammeter, sir.
Very good. This is an ammeter. Okay, this is called an ammeter. Now, what does an ammeter do? What is the function of an ammeter? Why is it used for? An ammeter is used to measure the current in the circuit. Okay, so it is used for measuring current. Okay, in amperes. It can be in amperes or small m capital A. This is called as milliamperes. Smaller versions are also available. Okay. So ammeter is used to measure current. And so what will be the unit of ammeter? The unit is ampere.
Amperes.
Okay, ampere is the unit of the current. Okay, so this is the same for ammeter also. Okay, next, fifth one. What is this called?
Galvanometer.
Galvanometer, sir.
Very good. This is a galvanometer. And what is the galvanometer being used for? Is it is used to detect the presence of current in the circuit. Okay. It is used to detect the presence of current. Current in the circuit. So that is why we use a galvanometer. Okay. And the unit of galvanometer, the unit is the divisions per ampere. Okay. It has got a needle which is usually in the center. Okay, if you've seen a galvanometer in the lab, before you connect it, the needle will be pointing zero divisions. Okay, once you connect it in any circuit and there is a potential difference, and when there is a current flow due to the potential difference, the galvanometer will show deflection. It will either deflect to the right or deflect towards the left. Okay, so when it deflects, the unit in the scale is the number of divisions per ampere. Okay, so divisions per ampere, or you can also say it is degrees also. Sometimes we refer it to as degrees. Okay, but usually it is number of divisions per ampere. So that's how we basically try to understand the unit of a galvanometer. Okay, the next one, sixth one. What about this?
Voltmeter, sir.
Yeah, this is called a voltmeter. So what is a voltmeter used for?
Used to measure potential difference.
Yeah, it is used to measure the potential difference in a circuit. Okay, that is why we use a voltmeter. Okay, so we have learned these circuit elements. We have some more. Let's see if you can guess them. What is this called?
Capacitor.
This is all very good. Sometimes we draw it like this also using parallel lines. Okay, yeah. So this is called a capacitor. Okay. What is the use of a capacitor?
It stores energy.
Very good. It is used to store energy. We also call it as an energy storing device. Okay. It is used to store energy. And okay, we didn't write the unit of voltmeter. Let me write that first. What is the unit of an voltmeter? It is,
Volts, sir.
yeah, it is in
Volts, sir.
volts. Yeah. And capacitance, we have seen, I mean, capacitor, we have seen. What is the unit of? Yeah, it is farad. It is called farad. Farad. In short, we write it as F. Volts also, in short, we write it as V. Okay. And for galvanometer also, in short, we write it as div by A. Okay. So these are all the appropriate units that you will have to know. Oh, fine. Moving on to the next one. The eighth one. What is this called?
Solenoid, sir.
No, this is called as that's correct. Solenoid coil is fine. We call it as inductor.
Inductor, sir. Inductor.
Yeah. Solenoid is, basically when you have a iron core inside. Okay, it is an inductor. Now, what is the use of an inductor? What does an inductor do? Unlike capacitor stores energy, what does inductor do?
Induce the flow of current.
Hmm?
Sir, induce the flow of current.
Induce the flow of current? Not necessarily.
Stores current, sir.
No, it does not store current. It is also storing energy, but in the form of magnetic energy. Okay. It stores magnetic energy. When current flows through it, it shows a magnetic field. Okay. So we can put it like this. It is a component which is used to store magnetic energy. It is a component used to store magnetic energy. And what about its unit, children? The unit of an inductor? It is called Henry. Okay, given by the letter capital H. Okay, Henry, we call it. Fine. The next one. What is this called?
Sir, bulb, sir.
Yeah, this is called a bulb. What is a bulb used for? It is used to produce light, isn't it?
Yes, sir.
Used to produce light or illumination. Okay, what is the unit? When you say it produces light, the unit of light is called lumens. Okay, or I mean, that is a higher version. We also call it as candela. Okay, if you would have learned the fundamental units, you remember light intensity.
Yes,
Okay.
sir.
Yeah. So these are all, the basic circuit components, okay, that you will have to be knowing. Okay. So with this, we'll proceed further. Fine. So now we are going to see the basic idea. Now we have looked at basic components. Now we are seeing the formulas. One by one we will see. So important formulas and concepts. Important concepts, definitions, and formula. So we'll see first one by one. The first one, electricity or electric current. So the formula for electric current, let us start. So the formula is, it's given, electric current is given by the symbol I.
Q by T, sir.
I is equal to
Q.
Q upon T. Very good. What is Q called?
Charge
Q
by
is
T,
called,
sir.
Charge, sir.
yeah, Q is charge in coulombs. Coulomb is the unit. Okay. and t is nothing but time in
Seconds.
seconds. And what is I called? I
Current,
is
sir.
Current.
current in amperes.
Ambient.
Okay, that's it. So technically speaking, 1 ampere is equal to 1 coulomb divided by 1 second. That is the relation between the units. Okay, so this is how we try to understand electric current. The rate of flow of charge, where it is I is equal to Q by T. The unit of I is in amperes. So you can say, when can you say that current flowing in a conductor or a wire is 1 ampere? We can say that current flowing in a conductor or a wire is 1 ampere when 1 coulomb of charge flows in it in 1 second. Okay, I hope that is clear. We'll go to the next one. So we have learned the electric current formula. Next, we have another formula for potential difference. Okay, so let's see.
V is equals to IR, sir.
Yeah, that is Ohm's law. One more formula is also there actually for potential difference. I'll tell you. V is equal to W upon Q. Okay, this is the formula for potential difference. So, what is potential difference? The work done, okay, in bringing a charge from infinity to a point. You call that as potential difference. So, you are doing work. Okay, so this is the formula for potential difference. Very important. Now, what is V? V is your potential difference in volts. And what is W called?
Work done, sir.
Yeah, that is work done in joules. And Q, it is charge in coulombs. That's it. Okay, this is about potential difference. All right. Next, third one. Now coming to your definition, Ohm's law, the formula that you said. Okay.
Okay, sir.
Yeah. Now, what is Ohm's law? How can we define the statement of Ohm's law? Okay, we will see that. According to Ohm's law, the potential difference is directly proportional to the current passing through it. Okay, or the current flowing through a conductor. Okay, provided temperature remains constant. This is what Ohm's law tells. So according to Ohm's
V
law,
is equal to
you
IR,
can
sir.
say V is proportional to I. So what do you understand by the statement? The potential difference is directly proportional to the current passing through the conductor. Now, when I remove the proportionality sign, what should I do? I have to introduce a constant of proportionality, and we call that constant as R. So R times I or I times R, both are same. Okay, this R is called a proportionality constant, called it's a proportional constant called as resistance. Is it clear? So that is your resistance. And unit of resistance already we have learned, it is ohms. And I is your current in amps
Ampere, sir.
or ampere. And V is
Potential difference,
potential
volts, sir.
difference in volts. Okay. So this is all that you will have to know. Is it clear? I hope the formula is clear now. You understood Ohm's law? V is equal to IR is the relationship. Okay. This is all about Ohm's law. This is the third concept and the formula we have seen. Now moving on to the fourth one. Okay. Next we are going to see the next concept we are going to see for today is the combination of resistors. So we'll see the combination of resistors. Now, what do you mean by combination? That means how to connect the resistors. What are the different ways in which connections can be done? Okay. So resistors can be connected or combined in two different ways, two basic ways. They are called as series combination. The second one is called parallel combination. Okay. So these are the two different ways in which you can combine. There is also a third combination. It is both parallel and series. This is a third combination. So these are the different combination of resistors. So we can combine or connect them in all these three possible combinations. So what is meant by series combination? Anybody? We are now going to see each one of them in detail. So what is series combination? The first combination.
The resistance are connected in series, sir.
Yeah? Anybody?
End-to-end connection.
When do you say resistors are in series?
When it is connected end-to-end,
So we say resistors are in series if they are connected one after the other. Okay. So one after the other, next to next, if you're going to connect them together, just like beads in a thread. Okay. We have seen how the beads are arranged in a thread, right? So the same way, that's a classic example of series combination. One after the other. A train engine and all the compartments. Have you seen how they are connected? That is nothing but series combination. Okay. Beads in a thread, the connection of bogies or compartments in a train. Okay. And the connection of flowers, okay, in a garland. So these are all classic examples of series combination. Now resistors are also connected when they are connected the same way. We call that a series combination. So first resistance, let me call it as R1. The second one is R2, R3, so on up to Rn, where Rn is the nth resistor. You can see that it is kind of a progression. Yeah. So what is the total resistance of this series combination? How to find out the total resistance? Okay, or the effective resistance. The effective or total resistance is nothing but given by the formula sigma I is equal to 1 to n Ri. Okay. When I expand the summation, what do we get? We get R1 plus R2 plus R3, so on up to Rn. Okay. This is the effective resistance, that is total resistance of all resistors connected in series combination. Is it clear? This is the first type of combination. Okay. Now we are looking at the second combination. Second combination is nothing but parallel combination. Okay. So how the resistors are connected in parallel? They are connected like this, one below the other. Okay, like how the ladder. Have you seen a ladder? So that is an example of parallel combination, like this, one below the other. The resistors are connected. If this is R1, if this is R2, R3, so on until Rn. This type of combination we call it parallel combination, and the effective combination of parallel is given by the relation 1 upon R effective is equal to 1 upon R1 plus 1 upon R2, so on up to 1 upon Rn. Okay, this is the formula. All right. So how do we write down this in summation? So 1 by R effective can be written as sigma I is equal to 1 to n, 1 upon Ri. Okay. This is the formula, children. Okay, for effective combination of resistors. That's it. Okay, so we have learned now what is or how do we find out the total resistance in series and the total resistance in parallel. So both the ways now we have seen. Okay, I hope this part is now clear. So with that, we are moving on. Okay, so series we have seen, parallel we have seen. Now let's see the questions based on this. Examples. Okay, we'll see some example questions. Determine the total resistance in the following circuits and hence calculate the total current flowing in the circuit. Okay, okay, this is the question. So I'll giving you different circuits. First one, this is the first circuit. Second circuit, this is the second circuit, and then the last circuit I'll give you the third one. Yeah, this is the third circuit. Okay, so this is a question. You will have to calculate what is the total resistance in the following circuits, and then you will have to calculate what is the total current in the circuits. So anybody is done? Solve the first part, first question,
Sir,
first
first one
and tell.
1.84 ampere. Sir, sir,
So what is the answer for the first question? What type of combination at least can you tell?
sir, series, sir.
The
Series,
first circuit,
resistors in series.
how the resistors are connected, whether
In
in
series,
parallel
sir.
or are they in series?
Series connection, sir. RS equal to R1 plus R2
You
plus
can
R3,
visually
sir.
itself guess.
Sir, RS resistance in series equal to R1 plus R2
You're
plus
just looking
R3.
at it. Yes, children.
Sir, formula RS equal to R1 plus R2 plus R3, sir.
So first one, anybody's tried? No idea?
Yes, sir.
You want me to show it?
Sir,
It's not difficult. It's actually
I
easy
is
only.
equals to 1.84 ampere, sir.
The first question. So the combination, what combination is it? Just now we have learned, if I'm going to scroll back, you can find out, right? By just looking at the circuit, isn't it? The second one here, it is parallel, which we have taught. The first one we have seen is series. Yeah. So what combination is this? The first one?
Series, sir.
It is series combination. Okay, you can see that they are connected in series. The first one is series. What about the second one? The second circuit?
Parallel, sir.
It is parallel. It's actually parallel, and here in between you can see it is series. These both are in series. Okay, combination. Third circuit, combination again. It's a combination of both series and parallel. Okay. So let's look at the answers now. Let's look
Sir.
and see the solutions
First one answer.
for the question. First question, you can see that you have to first find out the total resistance. Okay, the first one answer. So what is the total resistance? So it is R1 plus R2 plus R3. You just need to add them. 2 plus 4 plus 0.5 will give you how much?
6.5.
6.5, sir.
It's going to give you 2 plus 4 is 6. 6 plus 0.5 is, you will get 6.5 ohms, isn't it? So the total resistance, R total, is going to be 6.5 ohms. Okay, that's the value you will get. And
Sir,
you can see that potential is already given by the battery, which is 12 volt, right?
Sir, I is equals
From
to
Ohm's law,
1.8.
we know that V equals IR, and we want to find out I. So you rearrange for I. So I is equal to V upon R, which is 12 upon 6.5. Okay, it's 12 upon 6.5. This is what you get, isn't it? So simplify it. So 120 upon 65. How much is that? 120 by 65.
1.84, sir.
So you find the simplest fraction and then you can go for a simplification. Okay.
Sir, 1.84.
You must be getting somewhere around 1 point. I'm getting 1.8. Okay. Approximately 1.8, I think 4. Okay. So you must be getting 1.84 amperes. You're getting that answer. So the current flowing in the circuit is roughly 1.84 amperes. Okay. That is the total current. Is it clear? So this is how you find out. The same way for the second circuit. What is the total resistance? Oh, it's a combination here. So first simplify that series. So then you can see that 2, 4 and 0.5 are all in parallel. Right? So then you will have to solve it. So that's the second part. So the second part answer R effective for the series. I'm doing it. So 1 plus 3 is 4. Okay, and then you can see that all the resistance are in parallel, that is 2, 4 and 0.5. So our total, this is only for the series. Okay, for the series part in between. Okay, so then you can see that the total resistance 2, 4 and 0.5. So 2 is parallel with 4 and that is in parallel with 0.5. So for this, how do you do? So you will find out, use the formula for parallel combination where 1 by R total is equal to 1 upon 2 plus 1 upon 4 plus 1 upon 0.5. 1 upon 0.5 is 1 by 2. So therefore you just need to add 2. Simple. Okay. Now I think you guys know the shortcut trick to solve this. You can see what is the LCM. So 2, 4 and you have 2, right? So just you can multiply with 4 on both the sides. Okay. So 4 by R total is equal to 4 upon 2 is 2 plus 1 plus 8, right? I'm just multiplying with 4. So what is our total? It is 4 upon how much? 8 plus 2, 10 plus 1, 11, right? So 4 upon 11 ohms. So how much is 4 upon 11 ohms? Just go for a division. So 4 and 11, so 0 point, I think it goes 3, carry over 6, right? So our total is 0.36 ohms. Don't forget the units. So that is the total resistance. So once you've got the total resistance, can't you find out the current? So I is equal to V upon R, where V is 12 volts, okay, and R is 0.36. Okay, so 120 upon 36. So how much is that? 120 upon 36. So again you cancel. 3 point, I think it's recurring, no? So 3.33 amps. Okay, so current, we have clearly found out the total current as 3.33 amperes. That's it. Okay, so that's the answer for the second part. So second part, you see current is 3.33 amperes. Okay, so you can see that more current is flowing when you have a parallel combination. Okay, so the effective resistance in parallel combination is going to be lesser. That's the reason your current is more. Lesser the resistance, more the current will flow. You can see the resistance is only 0.36. But in series, what was the total resistance? It was more. It is 6.5. So more the resistance, you can see less the current. Are you understanding the logic? Okay. So higher resistance means what? Higher resistance infers lower current. Right. Okay. So higher resistance infers lower current. But here you have lower resistance. This means higher current or more current. Okay. Okay, that is higher current. Simple. So this is all you people have to keep in mind. Okay, that's it. Very simple. And last question, what is the answer for this part? Again, you need to find out the combination. You have two. So 2, you keep it on the left side. This, the right side, you have 2 and 2.5, no, which are in parallel. First you will simplify that. Okay, it's a 2-stage process for the third one. So you have 2, then you have 2 ohms on the top, and we had 2.5 ohms at the bottom. Okay, this needs to be simplified. So how can we simplify this? So 2, let it be there on the left, and right side you need to simplify it. You can use the formula. Okay, R total. Directly also you can use when you have 2. The formula is R1 R2 upon R1 plus R2. Now R1 R2 is 2 into 2.5 upon 2 plus 2.5, which is 4.5. Okay, this also will work. All right, which is 2 into 25 upon 45. 5 5s are 5 9s are. So 2 5s are 10. So 10 upon 9. Okay, so you need to find out the decimal. So what is 10 upon 9? 1 point something, right? So cancel it. So 1.1, again recurring 1.11. So the total resistance for parallel combination is 1.11 ohms. Now you find out the total. This is only for this parallel combination. We have only found out for parallel. Okay. So now combined resistance. You have 2 plus 1.11. How much is that? You just need to add it. When you add, you will get
3.11.
2 plus 1.11 is 3.11 ohms. So the total resistance that is effective resistance is 3.11 ohms. That's it. So once you have found the total resistance, now you can find out what is the current. So again, it's V upon R, so which is 12 upon 3.11. So how much is 12 divided by 3.11? So again, you can find out. Okay, I am approximating 3.1 into 3.1. Okay, for simpler calculations. So 12 and 31 threes are okay, 3.8, 3.87 we are getting. Okay, 3.87 amperes. So the current I is equal to 3.87 amperes. Done. That's it. Okay, so like this you can find out the current, right? So I hope it's clear. This is how you find out the resistance, effective resistance, and you can also find out the total current in any given circuit. So what we have basically done, what we have learned today is a circuit analysis. So we have analyzed the circuit, we have found out the total resistance, and hence we have also found out the total current. And we also have an important inference from solving these three different types of circuits. What is that? We understood that if resistors are connected in parallel, the total resistance is going to be huge, which results in a very low flow of current. The current is going to be less because resistance is more. But in contrast, we have also learned that if resistors are connected in parallel, the total resistance is going to be less, and hence the current flow will be more. Okay, so this is an important analogy that we have learned. The first circuit has got the highest resistance but the least current. Second circuit has got the least resistance but a higher current. And third circuit, you can see, has got, what about the resistance? The resistance is 3.11, and here it is. The first one was, I think, let me just check, 6.5. Yeah, it is moderate. Okay, it is in between. So it is 3.11. Again, it's quite bigger. And that's why the current is 3.87. Okay, so that's what you need to understand. Okay, so now the combinations, I hope it's now clear. So what are the combinations we try to understand? Okay, and we also found out what is the current flow and what is the total resistance also. Okay, so that is what we have learned for today. Okay, so this is the basic analogy. Now with this we are moving on. So we are moving ahead. Okay, so we are now moving on to the next part. So we looked at series, we looked at parallel combination. We have now learned how to solve circuits consisting of series and parallel combination both. Okay, so that's what we have done for the day. Okay, so with that we are going to move on to the next part. Okay, without any further delay. Now the next one is to calculate the current in the branches. Okay, finding branch currents. Okay, when there is splitting of currents in, especially in parallel combination, how to calculate the branch current is what we are going to see. Okay, calculation of branch current. So for that, let's take a circuit, a simple one. So my circuit is consisting of 3 resistors as connected here. First one I will take it as 2 ohms, and then here I will take it as 4 ohms. Here I will take it as 0.5 ohms or half ohms. Okay, now this entire combination I'm going to connect it. Say I'm connecting to a battery like this with a plug key. Okay, so I'm connecting it, I'm doing the connections, I'm marking the terminals of the battery, and I'm also giving you the value of the battery as well. Okay, so we are going to see the value of the battery. I just by mistake I didn't share. Let me reshare it. I think it's not visible. Let me reshare it. I think I pressed the wrong icon. Yeah, I've started resharing now. I hope it's visible. Okay, so we are going to see how the calculate the branch current. Okay, so I'll give you the potential difference of this battery. Say the potential difference of this battery is 18 volts. Okay, so the potential is 18 volts. Now we are going to find out what is the current. Now the direction of current always from positive to negative. So the current is going to flow clockwise in this circuit. Now as the current enters, you can see that there is a node or there is a junction. Now what is a node or a junction? It's a point where 3 or more wires meet. So this is called a node. Let me mark it as A and this node as B. So the current enters at point A and it is going to split. We'll call this current as I1, this current as I2. Okay, the current flowing through 4 ohm resistor is I1, the current flowing through the half ohm resistor is I2. So we want to find out what are the values of I1 and I2. Okay, for that first you need to find out what is I. So how to find out I? Find out the total resistance first. Okay, so you need to find out what is the R total. Okay, so these are the things that we'll have to do first. So simplify the circuit. So first step of simplifying, convert this circuit into a single resistor circuit. So this 2 ohms will remain. Right side 4.5 are in parallel. So I'm going to make it a single resistor circuit. And what is the value of that? 4 into half upon 4 plus half. Okay, so 4 into half is nothing but 2 upon 4 plus half. 4 plus 0.5 is 4.5, right? So 2 upon 4.5, which is 20 upon 45 in simple fraction. 4 5s are 20, 4 9s are 45, right? Sorry, 5 4s are right. My bad. This is 4. 5 4s are 20 and 5 9s are 45. So 4 upon 9 you will be getting, right? So 4 upon 9, so you will get 0 point something, right? So you divide it. So when I divide, 9 does not go, so 0.4. The next value also is 4. Yeah, so you get it as 0.44. Okay, so that is the resistance. So this is 0.44 ohms, and that is the second stage. Third stage, make it a single resistor. You can see both are in series. Add them. 2 plus 0.44 is 2.44 ohms. So the resistance is 2.44 ohms. So R total is 2.44 ohms. So once you've calculated R total, you can find out what is the total current. What's the formula? I is equal to V upon R total. That's it. Go and substitute. So V is 18 volts and total is 2.44. Simplify it. Okay, 18 upon 2.44. Okay, you can also take it as 2.4 for simplification. I am going to assume that it is 2.4 and then do it. So if I'm assuming it as 2.4 and if I cancel, so I will get, I'm also taking the reciprocal. Okay, so I'll get it as 180, 124. So then I will get 7 times it's going 7.5 you will get. Okay, so the current is 7.5 amperes, isn't it? So this is the total current, I total. Okay, so the total resistance we found now the current. That means this value of I is 7.5. So 7.5 amperes is passing through 2 ohms resistor and then it is entering this point A. That 7, out of that we have to find out how much is getting split. through 4 ohms and through half ohms. That is what is our task. So how do we calculate that? For that, we need to understand that when you have two resistors which are connected in parallel, the potential difference across them will be same. Okay, there are two important rules that you need to know. When resistors are connected in series, the potential difference across each of them is different. Okay, so the potential difference is going to be different. That means if I'm going to take many resistors, already we have just seen this concept. I'm again showing it to you. Okay, imagine the resistors having the value R1, R2, R3, so on up to Rn. Then what happens? According to the statement, the potential is going to be different across each one of them. The potential across R1 will be V1. The potential across R2 will be V2. Across R3 will be V3. So on. Here it is going to be Vn. That is what we try to understand, right? Okay, so it is different. Okay, but current passing through each resistor is going to be same. Okay, but current passing through each resistor is the same. Okay, that means same current is going to pass. So if current is I, it passes through all the resistors. So that is what you need to understand. So in series combination, in short, okay, for series, okay, so chill in just a minute, I'll get back. I'm getting a call. Okay, just give me a minute. Yes, children. So, in a nutshell, you can say that for series combination, what is same and what is different. Okay, we just need to try that. Okay, we need to understand that. So, in nutshell, for a series combination, we need to understand that current is same, but potential difference is different. Okay. That's all. So this is for series. Okay. For parallel, it is actually the opposite, the other way around. Okay. That also I'll give you. For parallel combination, the potential difference across each capacitor, across each resistor, not capacitor, is the same, while current flowing or while current is different. Is it clear? That's it. So this is what you will have to know. Okay. So these are certain things that you need to keep in mind. So again, for parallel, I hope the circuit is very clear. So you have resistors connected one below the other. Okay, like this. So this is R1 and this is R2 and R3. So potential difference will be same. V is same. Across R1, R2 and R3. While I is different. Okay. Why I is different? If current entering is I, now you can see that there is a junction or there is a node here. So current will get split. Okay. Across each component. The wire is splitting, isn't it? So current also will split. So across R1 it is I1, for R2 it is I2, and for R3 the current is I3. So you can say I is equal to I1 plus I2 plus I3. Same way for series, we can say the potential difference, you can build a relation. We can say V is equal to V1 plus V2 plus V3. Current is same, so you can't write I is equal to I1 and all. Okay, here I is same, so current will enter. So whatever current enters through R1 will also enter through R2, will also enter through R3, will also enter through Rn. So that is the logic that you need to understand for both series and for parallel combinations. This is very, very important. Okay, so once you understand this, questions based on circuit analysis will be easy. You will be able to do them. Okay, so these are the important golden rules that you need to keep in mind for both series combination as well as parallel combination. Okay, I hope this part is clear. Any doubts? So we have, entered the circuit analysis. So what is series, what is parallel, how to find out the current for series, how to find out the current for parallel combination of a given circuit, how to reduce the resistors, okay, for both series as well as parallel combination is what we have seen so far. Okay, so I hope I've taken you, until halfway through the chapter. Okay, so this is very important. That's the reason, I am showing you example questions also, the easier ones, as we are solving, as we are, running through the concepts. Okay, fine. Any doubts so far, you can ask, children, because even more I think it will go above your heads. So you have any doubts, you can ask. Anywhere you're stuck, okay, you can feel free, you need not feel shy, because we are here to help you guys. Okay, so wherever you're stuck, you can immediately interrupt, you can stop me, you have that freedom. and you can ask. Okay, so don't hesitate, because we are here to help you guys out, and you are here for to learn the concepts that is being taught. Okay, yeah. So we have to ensure that there is a two-way communication. So I hope everybody is listening. You guys are doing it, solving the questions proactively. Okay, I'm anyways going to share the PDF also in the group. Fine. So is it clear, children? So with this, we'll wind up for the
Yes,
day.
sir.
All right. So all these questions, please try them once again. I recommend all of you to try these questions once again. Okay. Just write the question. You tried solving it without seeing the solution, and then you try to do a compare and contrast. Check if you're able to arrive at the same answer. Okay. If not, you can just ping me on WhatsApp. All right. So we'll wind up here. Any doubts? You're free to ask.
Thank you, sir.
Otherwise, we can, wind up for the day.
Thank you, sir.
Thank you, sir.
Oh, circuit and elements also we have seen.
Thank you.
Okay, so I'm giving you a complete running notes. So right from here. Yes, children. Sharmila, did you understand?
Yes, sir.
I hope you're here.
Yes, sir.
Okay. Raji, what's your name? I forgot. It's showing here Raji Raji. But what is your actual name?
Santosh, sir.
No, you're trying to say something, but I'm not able to hear. Okay.
Santosh, sir.
Santosh. Okay, okay. Good. Okay, shall we wind up? Okay, so I want you guys to practice these questions. Okay, and you can get back anytime. Fine. Yeah,
Thank you, sir.
yeah. Bye bye, student. Take care.